Hi. So yes, I'm here to talk about stadium Wi-Fi, but everything that Keith sort of said is true in a stadium, and everything I'm going to say is kind of true everywhere else as well. Stadiums are just more like a normal office on steroids, and everything's a lot more complex, but it's the same type of rules, yeah. So we're going to break some rules, we're going to follow some rules, and you're kind of going to see. Now, when you start a stadium, the first thing the stadium owner, or whoever's going to run the stadium, is going to want to know is, how fast am I going to be? I want about the best experience, it's going to be the best thing for the end user, it's going to be awesome, and you're going to quickly find out that that's not how it works. So, what we have is, you go and see a customer, and they're going to, Keith already talked about, you go and find the requirements of the place, right? So you go to an office and you get the requirements of an office space, and the layout's the same. Everyone, you kind of know what everybody's going to be doing across the entire facility. When you have a stadium, things are very different everywhere. So you're going to have different requirements for different parts of the stadium. What you do in the bowl is you sit there and you take photos, you capture some video, and then you upload that to YouTube, Twitter, wherever it's going, right? So there's a lot of upstream traffic, but people don't necessarily move about, they sit still. Things like the Concourse has completely different set of requirements. People walk, they move fast, they go to the toilet, they go and stand in concession lines. So there is some of the same sort of things where you're standing still doing things on a mobile device, you're standing in a concession stand, but a lot of people move. So there's a completely different set of requirements. Things like when you sit down in a bowl, you know that there's going to be X number of people in the seats around you. If you're planning on spitball a number, an AP for every 100 seats, well then you know there's going to be 100 seats there, and that's going to be it. But in a concourse, you might design an area to be covered, but then there could be 2,000 people walk past, and that's completely separate. You've got to think about in-rush, out-rush. There's a lot of different things in the concourse. People move. Suites, again, very different again. A handful of people. Actually, suites generally maybe 20, 30 people in a large suite. They could be doing things like multicast video being streamed to them, and you know, those sort of higher end suites. Media, it's even less people, it's like 2 or 3 people in a booth, maybe editing video. Why they'd be on Wi-Fi, I don't know. It should be wired, again, they're not moving, plug them in. There's another place like back of house, you know, service corridors, that's really just roaming. People moving around, getting around the facility, again, another completely separate set of requirements. This one's the weirdest one. When do people arrive at a stadium? They don't all arrive at the same time, do they? No, there's generally games on before it, and you dribs and drabs as they come in. So your entry gate design isn't for that. It's for when everyone necks off. They all rush out. You empty a stadium of 70,000 people, they're all getting out straight away. And so being able to handle the rush of that many people running through an area and still maybe connecting. If they're being connected in the bowl, they're going to be connected everywhere else. So there's a lot of different bits. So when you go and do things around your RF models, you have to do these separately. You can't design and go, all right, I'm going to do an AP per 100 seats. Well, there's no seats everywhere, so you end up with different designs. But where's the primary part of a stadium? Any bowl, yes. So that's where you start, because everything then relates off that. So like when you do the office space of an enterprise, you don't start with the toilets, right? You start with, well, it's a critical area, but you don't start there, you start where people work and then work your way out. Same thing in a stadium. Yeah, Keith put up that wonderful picture of the hotel with excellent Wi-Fi but horrible backhaul, right? How do you gauge how much backhaul you're going to need for 70,000 people, 100,000 people? You need a lot, right? It's a massive amount. So trying to figure that sort of calculation out is not taking that sticker number of your data rates, 1.3 gig, and going, right, everyone's going to get 1.3 gig, times that by 50,000 people who are going to connect, and I need an awful lot of gigs of throughput. No, that's not how it works. We factor things in to that. Now, everything is based on sort of a restricted version of an enterprise. Keith talks about not having co-channel interference. You can't avoid that in the stadium. You can do your best to minimize it, but you're going to have a lot of it. You get to use every channel you can. Every channel depends on where in the stadium you're putting APs. Outdoor APs in Australia can't use Uni 1, so 36, 48. So the number of channels will change. So this calculation changes based on the area. So you're going to do those areas that we talked about before, and you're going to do a calculation for each of those. So things like your number of channels, your average throughput is based on the expected mix of devices. Least capable, most important does not exist in a stadium. It's whatever they bring in. Every fan should be able to be connected. So it makes doing those types of calculations and testing, right, am I getting the right signal strength in the right locations, very difficult. You will probably go and borrow Keith's Galaxy S3 and test it on that. Because depending on where the stadium is, how much money people have who go to the stadium, the mix of devices changes. So this average channel throughput tends to be kind of pegged around that 30 meg that's Keith brought up from a one-by-one device. You might get more than that, but you might get less. And then the reuse factor is how many times can I reuse these channels in the stadium and not have co-channel interference? There is none until you can prove it. You don't get to use channel 36 again in the bowl until you can prove you can do it without CCI. You're going to have to put them in anyway. You have CCI, there is no deleting it out of the bowl. So, this factor is sometimes hard to calculate. How many times can I reuse it again? In a big stadium, maybe like a MCG, something like that, like a big football stadium or cricket ground, that is a physically bigger stadium. Depending on how the RF is designed, you can get a fair chunk of reuse out of that to get that increased throughput. But this gets done for all those areas, your bowl, your concourse, all of it. But you don't just add them together. You add them together, you're going to get a very, very big number. Everybody, if they're in the bowl, they're not on the concourse. There'll be some in both, but you're not going to get it all. So it's a balancing number. But this gives you that guide to fix your backhaul problem. In your stadiums, everything is redundant. Stadium Wi-Fi going down during the middle of a game doesn't just impact fans, it impacts media, it impacts everything. So there is that. This is a guide. So when you go to the customer and say, and they say, how much do I need? Well, you've got enough idea. Right? What does a stadium design look like? This is, okay, it's still very similar to an enterprise. We just don't have a roof in this picture. But in an enterprise, you use walls, you use pylons, use everything you can to get channel reuse. You try and control where that RF goes, use directional antennas. We do the same things here. We just don't have 30 access points on the floor. We have maybe 600 or 700 APs in the bowl. So when you look at it, we get in a bowl, this one has no roof, so we can shoot stuff up. If we shoot things up, other APs can't hear them. Therefore, we get channel reuse. The clients, so if we're shooting an AP up here, the clients over here are not going to hear that. They will hear the other client, but there's nothing we can do with it. We can control the network side, right? So bowls, we tend to shoot out of it. Now you'll see when we have a bowl with a roof on it, it's the complete opposite when we shoot down. Things like suites, so like an office suite. Most of the times you will use an Omni. It's easy, you stick it in the back of it. But what you don't want is the coverage from here being seen all the way across here. So you push it to the back and you try and control it. It's all about controlling RF. It's the only way we can do these things and make them work. Concourses. Down and out. Get it away from the bowl. Remember, we designed our bowl first. Everything else we want to get away from it, work it away so we can get some reuse. And then your outer perimeter and stuff goes directly out. You'll notice none of these are pointing at each other. We're eliminating as much code channel as we can. You won't get the throughputs that you're after, particularly if you've gone through the Untitled system throughput calculation, come up with a number, and then you go and install it, and you get a fraction of it. It's probably because you've got way too much code channel. Your throughput's low. Now, there's two sort of major designs you can pick. In an office space, you hang them off the ceiling. You don't hang them like clocks. In stadiums, you've got a couple options. This one, beautifully modelled by Chuck, is under the seat. That's the one shooting up. We have an AP in the box shooting up. You notice things that I'm going to talk about in a minute, this wonderful tube. And you'll see why that's kind of important when I get to another slide. But these are designed to handle shooting up through the body. We use the body to attenuate the signal, therefore we don't have as much coverage out of an AP, which is what we want in the stadium. We want nice and close. We want plenty of signal for those people there, but we don't want that being heard 100 metres away. That was a Levi picture, yeah. When you got a roof, do you want to shoot up? Because it's going to go up, it's going to hit roof and then scatter and go everywhere and annoy everybody. We want to shoot down into the big bags of water that are people, let them absorb it and have radiation sickness. We'll shoot down. And then you use whatever you can to mount off. Under a seat you've got plenty of concrete. Up here you hopefully have some sort of gantries and that sort of stuff to hang off. And then we use highly directional antennas to give you some control. You're not going to put omnis 25 metres up in the ceiling and cross your fingers and hope for the best. We're going to control this with very directional antennas. Looking for ones with very controlled side lobes. If you have 100 APs, 200 APs running around the roof, they're kind of within your 2 metres of anything. You need to control that so they don't hear each other. And so we tend to split them up. You have something covering the low bowl, and you work your way up and you spread them out. That's your general type of rule, and you get sort of attachments like this. AP at the top, a nice long pole down, antennas hidden below the entry, keeping it away from the big chunks of metal. Now, sometimes you can't use an under the seat even though you have no roof. You have to think of other things, right? If you have no roof and you can't go under the seat, it's very, very difficult. You don't need to mount on. What do you do if you have a roof and you want to get the most out of it? Do you use overhead or do you use under the seat? Yeah, generally no. In our experience, the client will see the one overhead as much cleaner and not pick up the one on the seat. But there's always reasons why you don't end up with one or the other. You might go in, now this one is getting a roof. It's a material roof that is transparent to RF, so most of it will, unless it's hitting the structure, it will go straight through. So you could do under the seat. And most customers, when they build a new one, they will want an under the seat because they want the best performance. But there are so many little decisions that impact what you end up with. If it's a pre-existing stadium, can you get under the seat? Is there, if it's a brand new, can I get the coring done as part of the pour of the concrete? So my cables run through the concrete and I put my AP in a little box under the seat. One big problem in something like this when it's getting built, and they want the plan before they build it so they can put the coring in for the concrete, where do I put my APs? You can use Echo and you can plan a lot of this stuff. But what's in the concrete? Yeah, and how much of it? Is it built like Keith's two pitches? Is it built like that one was kind of dodgy and would fall down, or was it built one that's going to stand the test of time? You don't know, because that's not in CAD drawings you've got. So sometimes you have the best placement, and then you end up with an AP that is physically moved, and you have ducting. Back to the original, which is kind of that Levi's one, the AP was slightly off from where it was planned to be. Some places don't allow you to have ducts. Some places have vandalism issues. Particularly if you go out west of Sydney, where they tend to take ratchets in and under seats and throw them at each other. You get vetoed on doing under the seat because you can't put anything under there. Someone will throw a flare at you and they'll rip that up and they'll throw that at you too, just because you support the other team. It happens out there. Yeah. So suppose you could get all that sort of stuff right. Can I still go under the seat? Is there enough room under here to fit an AP? Is the mounting of the seats going to get in the way of where I want to put my APs? This one, there's heaps of room, right? This one, same stadium. There's nowhere to fit that under the seat. To add on to this one, this is removable. These things compact back and move back to give more floor space on the stadium. Where do I put an AP? How does it then collapse back? And then the big one, under the seat costs more. So that was a picture for UC. It's not paying attention though.
Thank you.
Don't you like that one? Under seat costs more. But then, got a pose for it?
Thank you.
Alright. So budget can veto pretty much every decision you make. And you'll be forever changing it. You might go, right, we can fit under the seat in the budget, and then as the project progresses, everybody else adds their bits, the contractors, the cabling guys, all those guys add their bits, and then you end up with miles over the budget, then you go and restart again and blow away everything you started, and go again. Now, generally, you would look, I had a picture here. It's not there anymore, but that's okay. I did say that floor plans aren't always true. You're going to get your requirements. You're going to ask them for the floor plan, so you go and start doing predictive in Becker-Howe and that sort of tools. This is a floor plan, if you didn't know. This is the concourse level of a stadium. So, not worry about the concourse. I'm looking at the lower bowl here. This all looks fine. I could, as far as this floor plan is concerned, I could go and put under the seat on it. But it's for the same stadium from those pictures earlier. This bit is all removable seating. Can I put under the seat there? Probably not. If I don't put under the seat there, how do I cover those seats? Can I do under the seat everywhere else and then do some sort of directional on that? The roof's generally 20-25 metres high. It means you've got a coverage area, even on a nice tight antenna of about 25-30 metres. This is 6 rows of seats. So you kind of veto the idea of doing combined on that one. To make this one worse, as another way of ruling out under the seat, all of that bit is built directly on earth. There's no space under it. So when you go to the customer and say, can I get under the seats? And they go, yeah, sure. I just didn't tell you that it's only for this bit. All of this bit, you cannot get to. But of course you don't know this until you go there. So, you take all this and you realise, okay, I'm going to go with an overhead. This is a stadium that's in the middle of being deployed at the moment, but we end up with overhead. Purely across all those things. Vandalism was a concern, budget was a concern, can't get under the seat, removable settings, all those things impacted that choice. From the customer's expectation that it was going to be the best stadium Wi-Fi ever. So we were starting to compromise right away. So you end up with a design similar to the one that I showed on this side before, where we've split it up with this. And then you take all that and you go and stick it in Ekahau and you start to model stuff. You go and put APs on the floor plan and there we go. So you end up with, that's about 150 odd APs. But if you marry this up with this one, we have an inner ring, a ring in the middle, which are offset, so horizontally offset, so AP1 as you go around the stadium, into AP2, and then one more. And that's what we started with. So you end up with that, and then you start to look at what sort of coverage do I get. We get our concentric rings of coverage, and we work our way out so that we have clients with highest now talking to the right APs. Problem number one, architects. Not only did they not like the look of this, they changed the stadium so that we couldn't do it. This became material, not a solid surface. They said, all we can do is mount off a gantry up here. So, even though right at the start we probably started with a RF design that was awesome, it was going to be under the seat, fantastic, and then we work our way down, we end up with a design that looks like this, and then the architect comes in and ruins the whole lot of it, and you start again. And then there's some valid reasons. This was going to come material, why couldn't we just move the APs up to the framework? Serviceability. How do I get to that when the only accessible part on the roof is this gantry horizontal? So you then end up with redesign number 3 and hours worth of work of moving APs around and making sure that when you end up with 3 APs pretty much attaching at the same point but staggered horizontally, that you get enough of that 2 meter clearance to keep them so they don't interfere with each other, even though they're on different channels. There's a lot of thinking as to getting that sort of flow to work. But you end up with what is essentially the same thing. Now, on this stadium, I'm kind of jumping between 2 stadiums, so just bear with me a bit. This one has a roof that goes all the way around. What happens if the roof doesn't go all the way around? How do you cover seats? This one kind of gives it away where it is. With a logo. What about this bit? Look at an enterprise, you've got roof. Even in this place you can drop things down off the roof. What do you do when there's no roof? We have our removable seating all the way around the front. We have nothing to mount off. We have to get inventive. Do we go at the front fence and point back? Can't really do that because the seats come out. But if we move it up to where the seats don't come out, can that work? No, because what about the people on the removable seats when they're in? Do we mount stuff right behind them and shoot down? Well, that's about 20 rows of seats. That's a lot of water bags to shoot through. So you start to look for other things. What else is floating around here? We have lighting towers. We have the scoreboard. But all those do is look at the direction those are pointing in. One offset of lights down there. All the other design was for the overheads pointing away. We're breaking everything by pointing forwards. We're almost intentionally causing co-channel interference. An AP up there will be heard over here. Very, very well. But if you don't put anything up there, all the little people down here in the cheap seats have nothing. Well, it's basically, you bought a cheap seat, you get best effort. best evidence, not great. So, there's other things you can tell from this picture. This stand from here around to here was built in 1990 something. This stand was built in the 2000s. It's a completely different design. There is one big problem. I think we're supposed to get a minute. This bit here overhangs the lower bowl. As you can see, this hangs down over the top. So there's about 5 rows of seats that cannot see anything mounted on the ceiling. Can't see the ceiling at all. So you then start to come up with these types of installs where you are specifically burying something up near the concrete. So Keith said keep 2 meters away from things. Well, we didn't. This is right up here because I don't want this guys down the front here seeing this AP at all. I want them talking to the ones on the roof. That's what we've designed it for, it's what we've engineered it for. We want this guy to cover 20 times 5, about 100 seats through there. And then you end up with all those around. Yeah, there we are. That's it. Sticking stuff on the roof isn't just as simple as taking an AP up and clipping a mounting bracket to it and throwing it up on the roof. Things need to be engineered. There are regulations on the roof, there's safety things. How do you get the cables up there? This was an early prototype of a roof mount for the same stadium. Cable tray, AP mounted, the antenna cables and power cables come back through, and you get a second version of it, and then a non-powder coated final version where the AP is mounted on the roof. AP cables run down the steel pipes and connect to the antennas. That's a cost you probably don't think of when you're designing the solution. How much does that cost times 150 of them? It's a lot of money. I saw custom engineering for this sort of thing. Sorry? And stainless. The other thing to consider is cable lengths. Not so much the Ethernet ones. The electricians can take care of that. Put more switches in, we'll make it work. The cable length from here to an antenna. When the antenna sits over the edge, there's a pair of them this thing. Those, when you go longer than 2 meters, at least for Aruba's outdoor APs, you need a lightning arrestor on every cable. That adds up real quick. So if you can keep the cable lengths to 2 meters or less, and it just has to do with conductance of the cable, you can have a lot less cost. It does mean another engineering issue of moving the AP closer to the edge. If you could have 6 meter cables and not be worried about the loss, you can stick the thing right back here behind the safety guide wire and it's happy. It's not how budgets work. Concourse. This was our first guess. Directional, remember we're putting down and out the concourse. We have a directional pointing away. We're using things like the steel beams to shield that from going back into the box. Remember we did our bowl design first, then we're working our way out. We have our AP off here, we have another AP up here. Who do you reckon vetoed this design decision? No! Electricians. They didn't want to run cables this far up. They had designed cable trays to run at this height. Not all out there. They didn't want to break out and go up. That's just an added cost. Things get expensive. So then you respin your design again, and you take this guy off here, and you try and put him down here. So you end up with directionals and omnis, trying to cover different things. Just to clear things up here, the blue things are directional, green things are omnis. So you'll see these ones are directionals pointing out. The omnis are hidden in the facade so that they cover the patrons at the concession stand and not really much else. They don't get that much further. They're nice and low, so they're going straight through the bodies. Yeah. This one's simple. we have a single set of concession stands running the whole way around on the outside. That's not how all stadiums work. We have stadiums like this, which has a concession stand running through the middle, and we have two concourses. Concession stands are double-sided. People go on both sides, therefore coverage on both sides. One problem you have, on the inside, from here to here is 3.5 meters. But there is zero signal coming down from the roof. So again, we break this rule. Bury it up here so that we're using the concrete to control the RF and shadow it out, so we don't get people in the seats down here using the APs that we don't want them to. This is designed to handle less density. It's designed to handle the people out the front of the concession stands, and the people that are still in the seats can still do their thing. So you end up with these mixed designs, but you're using the structure as much as you can. Like in an office, you stick it up on the roof and you've got clear space and everyone can see it for ages. You don't want that in a stadium. When your stadium has 600 APs and you get to use 21 channels, you want control. Cabling runs do make a big difference. This is the outer concourse. The original design was to put an AP on the wall and shoot it out. Follows the best practice of keeping the Wi-Fi pointing out of the stadium so it doesn't impact. As you go around the curve, everything points out. Things don't see each other anymore. Cabling costs to run a cable out and around this pylon to an AP and then get it going around the next pylon in and out makes things way too expensive. So you end up compromising and moving APs. You slide it out and you end up with an AP out here because the cabling can just run straight line around the outside, lowers the installation costs. But again, that's tweaking your deployment quite significantly, and you will re-spinning this design over and over. Service areas look like this. This is the same stadium, but they look completely different. This one has a cable tray. This one has a lovely drop ceiling. There are other parts of service where there's no roof at all. And so you start to come up with other types of designs. Drop ceilings are easy, but you can get away with a lower. Keith wants us to use high-end APs all the time because they work better in those scenarios, but when you've just got clients walking down a hallway, and we're going to break two rules here: cheaper APs and in a hallway, but they're only walking down a hallway, there's no rooms, right? So maintaining that. I reckon, yeah. So those are generally a little bit easier. This one though, it's a change room. When you look at a floor plan, you can see a lot of, if you get CAD drawings, you can see that things are concrete or they're cinder block or they're drywall, type of thing. This has a concrete beam. This is down in the very, very basement, so these are cinder block walls. Anyone know what a cinder block wall generally blocks? You would know. How much do you do? Big loss. It's concrete filled cinder block. And some Rio involved too. So, planning on an AP in a room, and then you go expecting coverage on the other side, you don't get it. Well, because you need to take ample samples. Visit the site and you'll see stuff. And even after you do all of this, and you get your 10th version of a design, when do you think things get deployed? In a stadium, it could be years. So your design can be completely different to what you actually install in the end too. But when you waited a long time and the contracts are all signed and they've built enough of the stadium, if it's a new one, to install stuff, you've still got stuff to do. If you're the installer, you have to aim antennas, and this is from Scott Lester, had a great little blog, there's a link down there, but on how to build this little aiming tool. Flips over the antenna, got a laser sight, points you where you need it to go, you adjust the tilt until it's aiming at the right spot, take it off, put it on the next one, and away you go. And so aiming, well, say it's 150 APs on the roof, 2 antennas for every AP is 300 times you've got to do some adjustments. And every time, this one, electricians can't follow rules. What was it? They can't get it within a metre accuracy, don't expect it, Keith, was that? Yeah. In a stadium, because it's such a highly engineered solution, you kind of want them to put it exactly where you want it. It doesn't happen. But so you're always updating your model as well. And you're going to walk around with a sidekick. You're not listening? I'm going to need one. Verify that you're getting what you expect. Of course, you're going to adjust that for your Galaxy S3 that you borrowed from Keith, and make sure that that sees the signal as you expect to. You get the right roaming and you get the right cell edges and the top. Now, after it's installed, is it ready to go? No. You've done all this testing when the place is empty. You need to test it when it's half full, 10% full, 100% full, all of them. And so you spend the next lot, as you see here, he's not paying attention if he is. You spend the rest of the time tuning, like a mechanic, yeah? And you're going to continue to do this. It's going to take a while to get it right. Yeah, you can have it. Yeah. This was about a week's worth of Photoshop after this. But yeah, tuning happens all the time. It's not sort of you set it and forget it in a stadium. Every event you're going to find something different. Every event has different quantities of people. It could be a completely different type of event. You could have a concert on the ground, and then you have to come up with a different sort of solution. Certain APs will be on, certain won't be. There's a lot of tuning that happens. It's not something like an enterprise. You bang it up, and then maybe every 6 months you come back and do a survey and double check that everything's good. Every event requires something different. Yeah.
Up there.
Yeah.
Otherwise, they're down here. You're shooting from the back. You get
Yeah. Yeah, there's so many things you have to think about when you do a stadium. It's not, I'm sitting at a desk with a laptop. I have, people don't sit still. People stand up, sit down, do all sorts of different things. But everything that you do in a stadium, everything kind of was the same. You have the budget constraints, you have electrician problems, you have the lovely architects that everybody loves. All those things are the same in enterprise. We just have to do it with a lot more thought and engineering, I guess, when you go for that bigger scale. But it's all the same stuff. You just get to break more of Keith's rules when you do that sort of thing. That's it, thanks.